In today's video, we're going to be looking at how to calculate the variance. Okay? Now, just like with the mean, with the standard deviation, etc., there exist two types of variances. There's the population variance and the sample variance. Okay? Now remember, the crucial difference is that the population is a group as a whole. Okay? Whereas the sample is an extract from that group. Okay? So here are the two formulas for each. So the population variance, as you can see, is equal to the sum of each data point, which is xi, I being however many data points there are, minus the population mean, mu, squared over the population size, which is capital N. Okay? Now in this video, we're going to be focusing mainly on the sample variance. So the sample variance, S squared, is equal to the sum of each data point, xi, minus the sample mean, x bar, squared over the sample size minus 1. Okay? Now as you can see, the only difference apart from the notation is the fact that for the sample we need to do n minus 1. So we add the minus 1. Now I won't get into why this is, as this is quite a complicated reason. Okay? Right, so how do we calculate the sample variance? Well, let's just take some random values, right, and see what we can do. So let's see. Let's take, why not 7 values? So let's take 3, 10, 5, 8, 13, 7, and 12. Okay. So we have 7 values. So there are 2 methods, okay, to calculate the variance that you can choose. So you can either construct a table, which is what we're going to look at first, or you can directly just use the formula, okay? Now the table can sometimes be easier, okay, to see. So in the table, we're going to have data, then we're going to have xi minus x bar, and then we're going to have xi minus x bar squared, okay? So this is going to be our table. So the data we said is 3. Let's see. 3, 5, 7, 8, 10, 12, and 13. Okay? Okay. So before we do that, remember, we need to find x bar, right, which is the sample mean. So in order to find the sample mean, remember, is the sum of xi's over n, right? So the sum of xi's would be this, right? Whatever the data summed is. So 3 plus 5 plus 7 plus 8 plus 10 plus 12 plus 13. Okay? So let's do that, see what we get. Okay, so we get 58. Okay? So this is the sum of all the data points. So then the sample mean is 58 over the sample size, which we know is 7, right? Because we have 7 data points. Therefore, the sample mean is equal to 8.29 approximately. Okay? Excellent. So now we have to do xi minus x bar. Okay. So x1, okay, when the subscript I takes the value of 1, would be the first data point, right? So 3 in this case. So x1 minus x bar would be 3 minus 8.29. Okay? That would give us minus 5.29. x2 would be the second data point, so 5 minus x bar. So 5 minus 8.29, that would give us minus 3.29. x3 minus x bar would be 7 minus 8.29, that would give us minus 1.29. x4 minus x bar, so 8 minus 8.29, minus 0.29. Then we have 10 minus 8.29, 10 minus 8.29, that gives us 1.71. 12 minus 8.29, 3.71, and then 4.71. Okay? Right, so now we have all the xi minus x bars. But now, remember, in order to do this part of the formula, right, we need to do first the square, okay? Right, so now we square the numbers that we got here, okay? So let's see. Minus 5.29 squared is about 27.98. And then we carry on, okay? 10.82. 1.66. 0.08. Then we have 1.71 squared, which is 2.92. Then 3.71 squared is 13.76. And finally, 4.71 squared, 22.18. Okay? Right, excellent. And then remember, we need to do the sum of, right, which is this part here. We need to do the sum of this part, okay? So basically we sum all these numbers, right? So let's see what that gives us. Okay, that should give us 79.4. Okay? Right, so now if we write down the formula for the variance, for the sample variance, s squared is equal to the sum of xi minus x bar squared over n minus 1. Okay. So we have the sum of xi minus x bar squared. Okay, we know that that's 79.4. And then we do n minus 1. Okay, now n we know is 7, right? The sample size is 7 because we have 7 data points. So then we do 7 minus 1, which is 6, and then we solve, right? So that should give us 13.23. Okay? So that's our sample variance, okay? Excellent. So that was the first technique, right, is doing this table. The other technique would be to just directly use this formula, right? And so the way you would go about this is you would simply, it would be a long formula, right? But you would do, so you first do the first data point, so x1 minus x bar. So x1 was 3, and we said the sample mean was 8.29. So 3 minus 8.29 squared. Then plus, right, because this is the sum of. So plus, and you do the same for the second data point, okay, which we know 5. So plus 5 minus 8.29 squared. Then the third one, 7. 7 minus 8.29 squared. Okay, and you would go on up to the last data point, which in our case is 13. So plus 13 minus 8.29 squared, and then this whole thing over n minus 1, right? The sample size minus 1, which we know is 7 minus 1. Okay, so you can go check during your own time if this gives you the same answer, as it definitely should. And yeah, so then you get to choose which method you use. The table is easier to not make any mistakes, but yeah, it's up to you to choose. Okay, right, so that's it for today's video. I hope this is clear. Let me know down in the comments if it's not, and I'll be happy to help you.